Hey guys, welcome to this new story. Before we go anywhere, take a moment to get comfortable. Let your body rest in the place you've chosen for the night. Move your pillow if it helps. Let your shoulders loosen and let the day's tension slide away. You don't need to do anything right now. Nothing to think about, plan, or remember. For the next 2 hours, all you will do is listen and let your mind follow this journey with your eyes closed. In this story, you will travel slowly on a space station above Earth. The planet turns below, lights flickering in cities, oceans stretching far, clouds floating over mountains. Nothing will rush, nothing will interrupt you. This experience is designed to help your breathing settle and your mind settle as you follow along. I'll be here at the start, guiding you gently, and then, step by step, I'll fade, letting your imagination watch the planet below. As we begin, imagine yourself weightless, safe, supported, and free from hurry. Beneath you, Earth moves in patterns older than any memory. Rivers, forests, and coastlines pass without notice. The lights of towns blink slowly, unseen from this distance, untouched by time. We will travel together, slowly, carefully, at a pace made for resting, for noticing without effort, for letting go. For now, let your body settle and allow this night above Earth to start. The world below is familiar, yet from here it changes. Shapes become patterns. Lights shift. You will feel the difference of seeing Earth from this high, moving quietly in the black of space. You are aboard a small craft, leaving the surface. The engines hum with steady power. Outside the windows, the sky darkens, shifting from deep blue to black. The last traces of sunlight fade along the horizon. Clouds are visible still, soft and thick, reflecting the final colors of evening. You can see cities beginning to glow faintly in the growing darkness, tiny islands of human presence among oceans and land. The craft rises steadily. Gravity lessens gradually until your body feels lighter, as if it is slowly letting go of the earth below. Your hands feel weightless when you lift them. Your legs, no longer pressed down, float almost freely. Every movement takes a little adjustment. You find yourself moving differently, learning how to control motion without the constant pull of the ground. It is gentle, not startling, but always present, the sensation of your body learning a new language. Ahead, the space station appears, a series of connected modules, solar panels spread like wings. It glints in the sunlight, metallic surfaces reflecting the last rays. It is large, yet every detail is visible. Docking ports, tiny antennas, small windows, all carefully arranged. There is a quiet precision in its structure, a sense of order. You move closer, engines slowing, aligning with the station's docking corridor. Outside, the blackness surrounds everything. Yes, there is no up or down here. Orientation is measured by light and by the station itself. The stars hang still, pinpoints of white against the infinite black. The docking approach is slow and controlled. Small thrusters adjust position in tiny bursts. The craft rotates slightly to match the station's angle. You notice shadows cast across the modules, changing subtly as the sun moves. There's a rhythm in the adjustments, a pattern of motion that feels deliberate and exact. You hear the soft clicks and whirs of equipment, life support systems functioning, computers coordinating alignment, the craft responding obediently to every command. Outside, the station waits, patient and fixed in orbit. Inside, the cabin is minimal but familiar. Seats hold you in place during the final approach, but soon restraints are removed. Your body stretches as the last moments of acceleration pass. Light filters through small windows, catching on your hands and face. Reflections of the station's structure pass by in a gentle, continuous shift. You notice how the curvature of the Earth begins to curve beneath you, the horizon bending subtly as altitude increases. Oceans shimmer with moonlight, continents dark but patterned with tiny sparks of city lights. Clouds move slowly over the surface, their shapes changing even in the brief moments of observation. It is calm, steady, almost hypnotic. The final docking is precise. Mechanical latches connect your craft to the station's port. A subtle vibration runs through the hull. There is a pause as systems equalize, pressures stabilize. Doors unlock, and you float forward, guided by handrails. Air smells neutral, recycled, slightly metallic. Light is steady, artificial but soft. Every surface is carefully maintained. Modules connect like segments of a long tube, passageways framed in white and gray. You move carefully, learning to push and pull without weight, letting your hands guide you along the walls. There's an ease in the motion once you adjust. The station becomes your temporary home. From the windows inside, Earth expands below. Night spreads across continents, and city lights glow like sparks on dark cloth. Rivers reflect the moon, thin threads of silver running through the land. Clouds drift slowly across the surface, forming intricate, shifting shapes. You can see large storm systems forming, spiraling gently, hints of lightning flickering far. Below, the atmosphere is thin but visible as a pale layer along the horizon, a soft curve separating the black of space from the blue of the planet below. It feels fragile, delicate, yet complete. Every glance reminds you of the scale, the complexity of this living, moving sphere. The station hums around you. Fans circulate air quietly. Screens and indicators blink with soft light. Small touches, like grips along the walls and padding around corners, show careful thought for life in microgravity. You float from one module to another, noticing the difference in function. Some areas are meant for observation, with wide windows and minimal obstruction. Others are for work, with instruments, computers, and control panels. You run your hand along a smooth surface, feeling its cool metal, sensing the precision that built this place. It is a machine, yet it is alive with purpose, sustaining life in the harsh environment of orbit. You pause at a window, letting your eyes follow the curve of the Earth. The horizon bends gently. Clouds reflect city lights faintly. The ocean stretches like a dark mirror, calm but vast. You notice the colors shift as the station moves in its orbit. Dusk and night alternate rapidly, colors changing subtly, clouds moving in patterns that suggest wind and weather currents far below. You begin to sense the motion, not just of the station, but of the Earth turning beneath you. It is a slow, almost imperceptible spin, yet constant. Each glance shows something new, a river gleaming, a mountain shadow stretching across a plain, the glint of ice at a pole. The planet is alive in movement and in light. The transition to microgravity continues to settle in. Your body floats with ease, movement smooth and measured. Small adjustments are made automatically. A push off the wall here, a gentle pull with fingertips there. Objects respond differently. A pen released floats slowly, turning as it moves. Air currents are minimal, yet perceptible if you concentrate. Even breathing feels different, each exhale and inhale having a slight sense of expansion without the grounding of gravity. You notice every detail with a new clarity. The weight of a hand, the motion of a floating tool, the delicate light patterns across surfaces. Outside, the station orbits silently, a mechanical companion to the planet below. Solar panels adjust gradually to catch sunlight, glinting softly. Small shadows shift across the modules, following the sun's path. You can see the Earth rotate beneath, continents slipping past, oceans dark and reflective, clouds forming and fading like smoke. Storms appear distant, yet visible, movements subtle but precise. Lightning flickers occasionally, bright and quick, illuminating parts of the cloud tops for a moment. From this perspective, the world seems slow, deliberate, measured. You begin to feel the rhythm of orbit, the cadence of day and night, compressed into brief cycles. You float through the station, noting details along the walls, instruments, labels, small personal items left by crew. Every object has a place. The layout reflects decades of experience and planning. The station is a home, but a specialized home where life is conducted carefully and deliberately. You adjust your body to move between areas, learning the subtle art of momentum. Push too hard and you spin, move too gently, and progress is slow. There is a balance in every motion, a dance of physics that becomes natural with observation and practice. From the observation deck, you look down at Earth again. City lights glimmer, forming networks that trace the movement of humanity. Rivers and lakes reflect moonlight, mountains cast long shadows, ice reflects with a pale, steady glow. Clouds drift across land and water, occasionally thick enough to hide the surface entirely. Winds shape patterns across deserts and forests. The view is continuous, seamless, unending in detail. Every orbit brings a new angle, new light, new perspective. You notice the subtle changes, the way storms move, how night gradually spreads across continents, how the curvature emphasizes the planet's roundness. There is a calm precision in watching, a patient observation that allows the mind to settle into rhythm. The craft that brought you here has left, and now you are fully part of the station. The hum of life support, the motion of orbit, the gentle rotations of the station all form a background, a constant presence. You move carefully, letting your hands guide you along rails, pausing at windows to watch the earth. The colors shift slowly, shadows moving, storms forming and fading. The lights of cities appear and disappear, following the rotation of the planet. Every glance brings new understanding, subtle, measured, continuous. You begin to feel the quiet rhythm of life in orbit, the delicate balance of observation, motion, and time. The body continues to adapt, muscles adjust, blood flow shifts, movement becomes precise. Floating becomes second nature. You notice your own breathing, the rise and fall of your chest, the small sounds your body makes. They blend with the hum of the station, the faint click of equipment, the distant soft thrum of mechanisms operating. Every sound is measured, every motion deliberate. Observation is constant. You look down again, noticing the small differences in cloud patterns, the shimmer of light on the ocean, the way shadows move across the land. The station is your vantage point, the planet below your focus, and the motion around you feels like a gentle pulse, steady and unbroken. Once you have adjusted to the station, life in microgravity becomes a quiet, steady routine. Your body has learned to float without effort. Each movement begins with a gentle push from a wall, a handrail, or the floor beneath what you think is your feet. Momentum carries you forward, but only for a short distance before the next motion is needed. There's no need to walk, no resistance from gravity, yet every action requires attention. You become aware of how small gestures shift your position. A turn of the head, a breath, or the release of a hand can alter your path. You learn to move slowly, deliberately, letting the station's environment guide you. Objects behave differently here. A pen once dropped does not fall. It spins, floats, and drifts across the cabin. You watch it, noting the subtle forces of air movement, the pull of your own hand if you reach for it. Cups, tools, notebooks, everything has its own pace when released. Even a simple item can become a small observation of physics in action. You learn to anticipate these motions, to reach and guide rather than grab and hold. There is a calm patience in watching how things respond, a constant awareness that every motion produces its own effect. The station itself seems alive with small motions. Fans circulate air, creating barely noticeable currents. Light from the observation windows shifts as the station orbits. Solar panels slowly tilt to catch sunlight, and shadows crawl along the modules. Even the hum of machinery seems to have rhythm, a gentle beat that fills the background. You float through the halls, grasping handrails as needed. A small push sends you gliding, and you adjust with tiny tugs on the walls. Each movement is measured, precise, yet effortless once you have learned the patterns. Sleeping in microgravity is an adjustment of its own. You do not lie down in the traditional sense. Instead, you secure yourself with straps or inside a small sleeping bag attached to the wall. Your body is free to float, but the restraint keeps you from bumping into equipment or walls. The feeling is unusual at first. Your limbs move lightly with each breath. Your chest rises and falls without weight to pull it down. Eyes close, yet the sensation of floating remains. You become aware of the quiet shifts in your position, the slight changes in orientation, and you learn to surrender to the gentle stillness of the cabin. Meals require attention. Liquids are contained in small pouches with straws. Solid food is wrapped to prevent pieces from floating away. You bring each bite carefully to your mouth, mindful of how crumbs and droplets behave. Eating becomes a deliberate process, slow and measured. You notice the textures differently, the way gravity no longer presses on food or water. You swallow with a slight awareness of your own body's adjustments, the movement of liquids in your mouth, the sense of mass moving in a weightless environment. Everything is familiar, yet subtly altered. Daily work continues in microgravity with its own rhythm. Instruments, computers, and controls are arranged to accommodate floating movements. You pull yourself along rails to reach equipment, using both hands and feet to stabilize when needed. Each task requires precision. A tool released without care may drift away. A pen might float off to the side. You learn to anticipate these small motions, to guide each object, to work with the physics rather than against it. Movements become smoother with practice, flowing naturally from one task to the next. The sense of orientation can shift easily. Without gravity, up and down lose meaning. You learn to orient yourself using the station's layout, visual cues, and light. Sometimes modules appear to rotate around you. A turn too fast, and your vision adjusts in unusual ways. Your body feels slightly disoriented until the inner ear recalibrates. You become attentive to these changes, adjusting slowly, breathing deliberately, letting your body find its center. Each corridor, each room has its own reference points. A window here, a handrail there, the position of screens and equipment. These guide your movement, your sense of balance, and your awareness of space. Bathrooms are designed for microgravity. Using them requires careful technique, and everything is secured: water, waste, and air. Circulation are all controlled with small systems. You notice how even the smallest processes, like washing hands, brushing teeth, or drinking water, are altered by the absence of gravity. Each action is deliberate, measured, mindful. You become aware of the subtleties of motion and the influence of the environment on the simplest tasks. Repetition teaches mastery. The body learns the new rules and adapts without conscious thought over time. Observation continues in parallel with daily life. You float to the windows and watch Earth turn beneath you. The night shifts across continents, oceans, and clouds. City lights sparkle in dense clusters or faint networks, highlighting human settlements. Clouds drift over land and water, forming patterns shaped by wind and weather. The curvature of the Earth is subtle yet noticeable. Each glance offers a new detail: the glint of ice, the shimmer of rivers, the changing shapes of clouds. Microgravity allows you to remain at the window, suspended, in place, observing without effort, gently carried along with the orbiting station. Exercise becomes a conscious part of life. Without gravity, muscles weaken over time. Specialized equipment allows you to move against resistance. Pedaling, pulling, stretching. Each action keeps your body strong. Movements feel different, but the resistance creates a rhythm. You notice your heartbeat, the flow of blood, the subtle movements of the body as it works to maintain strength. Even a simple stretch becomes an observation of how the body adapts to weightless conditions, and a reminder of how finely tuned human physiology is to gravity on Earth. Airflow is perceptible if you pay attention. The fans hum constantly, circulating oxygen, moving gently along surfaces. Small particles, dust, or even your own breath float in slight currents. Tiny adjustments are made by moving hands or shifting body position. You notice the way air carries sound differently, how voices echo softly in modules, how each movement of your own body interacts with the environment. The station is full of small, precise motions that are easy to overlook, but essential to life here. Even simple gestures take on new meaning. A hand raised slowly glides forward. A body rotation requires only a gentle push. You become aware of inertia in ways impossible on the surface. Each push has a follow through. Each grab redirects motion. Movements are intentional, careful, yet elegant in their simplicity. Over time, your body integrates these lessons. Microgravity becomes second nature. You move fluidly, almost without thinking, and your attention shifts naturally from effort to observation. Crew members, if present, share the same environment. Movements are coordinated to avoid collisions. Voices carry softly, blending with the hum of equipment. Small routines are synchronized. Work and rest coexist seamlessly. You observe one another's movements, noticing the subtle art of floating, the gentle corrections made with fingertips, the careful use of handrails. Cooperation becomes intuitive. Life in microgravity is shared, yet individually experienced through every breath, every push, every glance at Earth. Sleeping patterns follow the orbit. You notice the compression of day and night, each orbit taking roughly 90 minutes. Light enters through observation windows in cycles, shifting from sunlight to darkness. The station moves quickly around the planet, yet your body adapts to the repeated sunrise and sunset. Microgravity affects sleep subtly, but with gentle routines, your rest is uninterrupted. You float, adjusting position occasionally, noticing small shifts in air currents, subtle movements in the cabin while the planet rotates silently below. Objects remain close if managed carefully. Tools, devices, personal items, they all require mindfulness. A notebook left unsecured might float into view later. Even water behaves differently. Droplets form spheres, moving along surfaces, or floating freely until guided. You learn patience, a deliberate motion, and careful attention. Simple acts, eating, drinking, writing, become lessons in physics, observation, and adaptation. There is satisfaction in mastering these small challenges, in understanding how the environment shapes every action. Time itself is noticed differently. Without gravity, without the slow pull of weight, the body and mind adjust to subtle rhythms. You float along schedules, moving from task to task with gentle awareness. Observing Earth from orbit becomes a continuous backdrop to these routines. Night spreads across the surface, city lights glimmer, storms drift slowly. You feel connected to the planet yet separate, a passenger in orbit, your senses attuned to the station, the planet, and your own shifting body. Life continues, precise, deliberate, gently unfolding in weightless harmony. From the observation deck, you look down at Earth as night spreads across the planet. Darkness covers continents, oceans, and deserts. Yet the night is not empty. Lights flicker across the surface. Cities glow in clusters, some bright and dense, others faint and scattered. You notice the shapes of these lights, tracing the edges of roads, outlining towns, and marking the presence of human life. Rivers of illumination follow highways and coastlines, creating patterns that shift as the station moves overhead. You can distinguish regions by the density of light. Large metropolitan areas shine like small constellations, their brightness reflecting population and activity. Smaller towns appear as soft points, isolated yet clearly defined. Villages emerge intermittently, linked by lines of faint light that trace transportation networks. The contrast between urban areas and surrounding darkness is striking. Mountains, deserts, and forests appear almost entirely black, interrupted only by the glow of human settlements. You notice how these patterns repeat, how they change subtly from orbit to orbit depending on local activity, the position of clouds, and the angle of light reflecting from the atmosphere. Clouds pass over the illuminated surface. From above, their forms are slow and deliberate. Some are thin and scattered, casting faint shadows over cities. Others are thick, opaque, obscuring the lights entirely. Occasionally, a storm is visible in the distance. Lightning flashes inside dense clouds, brief and powerful, revealing the structure of the storm for a moment. You watch these flashes carefully, noting the movement, the shape, and the scale of the system. Even in the vast darkness, these details are visible, allowing a quiet understanding of how weather moves across the globe. The oceans are dark, vast stretches of water reflecting little light. Sometimes, moonlight touches the surface, creating narrow silvers of reflected light. You see the waves from above as soft patterns, subtle undulations that hint at motion without giving precise form. Currents and tides shape the surface continuously, yet smoothly. Ships sometimes leave trails of light, isolated points that move slowly across the dark water. You notice how human presence on oceans is minimal compared to the vast darkness, yet distinct when it appears. Islands appear as faint shapes, dotted with small lights, isolated in the dark expanse of water. Auroras appear near the poles. You watch them slowly shift in color and shape. Green waves ripple across the night sky, occasionally mingling with reds and purples. The forms are delicate, layered, and constantly moving, responding to solar wind and Earth's magnetic field. From this perspective, the auroras feel immense, covering large regions, yet thin in density. You notice the contrast between these natural lights and human-made lights on the surface. Both are beautiful, but the auroras have a subtle, fluid motion, while cities remain fixed in place. The interplay of these two types of illumination highlights the complexity and variety of light across the planet. Atmospheric layers are visible near the horizon. A thin band of color separates the blackness of space from the surface below. This layer catches the last rays of the sun, faintly illuminating clouds and the edges of continents. You can see how light bends and scatters in the upper atmosphere, creating soft gradients that shift as the station moves. The transition from day to night is visible in real time. Shadows lengthen, clouds darken, and the glow of city lights becomes more pronounced. You notice how subtle these changes are, yet how continuous and inevitable. The movement of the station compresses hours of transition into moments of observation. Storm systems are striking from this altitude. You see spirals of clouds forming large circular patterns. Some storms are isolated, spinning slowly, while others stretch across entire regions. You notice the direction of rotation, the density of cloud cover, and the occasional flash of lightning. Inside the mass, the scale is difficult to grasp from the surface, but from orbit, it becomes tangible. You can trace the paths of storms over time, the way clouds advance, merge, or dissipate. Even the smallest details, such as breaks in the cloud layers revealing cities or water below, become visible. Observing these systems quietly gives a sense of patience and time, a reminder of the ongoing processes that shape weather across the planet. You follow rivers of light along the ground. Major roads glow like threads, connecting dense clusters of settlements. Highways curve around mountains, rivers, and valleys, following the contours of the land. Each light trail is a record of movement, of people traveling at night, of activity continuing after sunset. Occasionally, you see a temporary blackout, a gap in the network where lights have gone dark. It could be a cloud, a change in electricity, or simply a pause in human activity. Watching these flows of light, you begin to sense patterns of population, movement, and the rhythms of human life at night. Deserts are dark, mostly empty stretches of land. Occasionally, small settlements or mining operations appear as faint glimmers. Sand dunes and rock formations remain invisible except for subtle shadows at the edges of artificial light. You notice how the emptiness contrasts with urban clusters. Forested areas appear dense and black, with occasional lights from research stations or roads cutting through. Mountains are visible by the shadowed lines they cast over cities or valleys. From orbit, geography becomes a mix of darkness and illumination, motion and stillness, where each element tells a story in light and shadow. The curvature of Earth is apparent. Horizons bend gently, revealing the roundness of the planet. Clouds drift across this curved surface, their movement slow yet constant. The night sky stretches above, a contrast of infinite black peppered with stars. You notice how layers of atmosphere, city lights, and cloud shadows overlap. The perspective emphasizes scale, highlighting the size of continents, oceans, and storms. Even small villages become noticeable, framed by the larger patterns around them. Observation becomes an exercise in noticing relationships, how light and land, weather, and human presence interact in a continuous, unfolding view. You watch faint patterns in the oceans. Ships leave streaks of light, small movements across vast, dark waters. Reflections of lightning inside distant storms catch the eye for a moment. Cloud shadows create soft changes in darkness. The motion is subtle, slow, continuous. Rivers, currents, and tides are imperceptible in detail but apparent in overall movement. You notice the way the Earth rotates beneath, completing a full circle in less than a day. Each orbit of the station gives a new angle, new light, and new detail to observe. Patterns shift, change, and sometimes repeat, creating a quiet rhythm that mirrors the movement of the station. Small settlements in remote areas appear as tiny clusters. Their lights are isolated from larger cities, but they are distinct. Roads leading in and out are faint threads of illumination. You can track the connection between human presence and geography. Sometimes, the pattern of lights shows the course of a river, the outline of a valley, or the edge of a mountain range. You notice that human activity is most apparent where light is concentrated, yet even minimal settlements are visible in the dark expanse. Observation becomes both scientific and meditative, an awareness of scale, placement, and movement. Cloud cover changes continuously. Some layers are thin, creating subtle shadows over the landscape. Others are thick, hiding the surface entirely. You see gaps opening as clouds move, revealing glimpses of rivers, cities, or coastlines. You notice the layers of clouds at different altitudes, their movement independent yet interconnected. Some drift faster, others remain nearly stationary, influenced by wind and temperature variations. Storms develop slowly, dissipate, or move along predictable paths. Observation requires patience, a continuous attention to detail, and a willingness to watch without interruption. Auroras continue to appear in polar regions. Their forms are constantly changing. You watch green, red, and purple waves ripple and fold across the upper atmosphere. They appear faint from some angles and bright from others. The patterns interact with the curvature of the Earth, creating shapes that stretch across hundreds of kilometers. You notice how the auroras move with time, responding to solar activity, yet maintaining a steady rhythm. From orbit, the view emphasizes the vastness of these natural lights, their difference from human illumination, and their role in Earth's atmospheric dynamics. Lightning within storms illuminates cloud layers in sudden flashes. You notice the structure revealed, towering columns, swirling forms, and occasional breaks where the surface below becomes visible. The brightness is brief yet intense, creating a momentary map of the storm's interior. You follow the timing of flashes, the movement of clouds, and the occasional reflection of light on distant waters. Each strike is an instance of power, observable from a safe distance, highlighting the interaction of atmosphere, electricity, and weather patterns. Your attention shifts to subtle reflections. Moonlight glints on rivers and lakes. Snow covered mountains catch the faint light of distant cities. Clouds above oceans reflect light from storms or settlements. You notice the interplay of natural and artificial illumination. Observation is constant, though yet gentle. Your mind follows patterns without effort. The orbit of the station provides a changing perspective, a rhythm of movement that contrasts with the stability of the lights and shadows below. Each glance is different, yet each reveals continuity. Night continues its spread. As the station orbits, continents rotate into darkness, oceans pass beneath in constant motion. Cities remain bright, yet the density of light changes with distance and cloud cover. Storms shift, auroras fade or intensify, clouds move continuously. You notice subtle differences with each pass, new flashes of lightning, changes in road illumination, shifting shadows of mountain ranges. Observation becomes both detailed and continuous, a gentle rhythm of watching the world below with patience, awareness, and quiet attention. Microgravity allows you to remain suspended in place, to watch without effort, to be part of the orbiting rhythm while Earth performs its nightly cycle below. You move closer to the large observation window and let your gaze linger on the layers of the atmosphere. From this altitude, the sky is not just black. There is a thin, pale line at the horizon where air meets space. This layer shifts in color as the station orbits, from soft blues to faint pinks and oranges when the sun is near, fading gradually into the dark of night. You notice how the light scatters, bending along the curve of the planet. Even from this height, the thinness of the atmosphere is apparent, a delicate skin around the planet, protecting and shaping life below. Clouds drift beneath you in patterns that are both familiar and strange. Large storm systems stretch across continents, swirling slowly in wide spirals. Smaller cloud clusters move independently, shaped by local winds and temperature differences. You can follow the paths of clouds as they move across deserts, oceans, and forests. The texture varies. Some clouds are thick and white, almost solid, while others are thin and wispy, like strands of smoke spread over the surface. Shadows fall over land and water, creating a three-dimensional effect that highlights the topography and movement of the clouds. You observe the edges of storms. Thunderstorms rise in towers, dense and bright from reflected sunlight. Lightning flashes within them, sometimes hidden, sometimes illuminating the interior structure. You note how clouds above the storm are layered, each with its own density and shape. From orbit, the scale is easier to understand. A single storm covers hundreds of kilometers, its energy immense, yet it moves slowly compared to the station. You watch the motion, the rotation of the system, and the development of cloud bands. Every detail is visible: the curve of a spiral, the break of a cloud top, the faint glow of precipitation below. Clouds over oceans behave differently than those over land. Sea breezes create long lines of clouds, stretched and orderly. Storms over water can be isolated or part of larger systems. You notice subtle color differences. Clouds catching sunlight have warm tones, while those in shadow are cool gray or faint blue. Moonlight at night touches the tops of clouds, creating soft highlights, making them appear silver or pearl-like. Light reflection varies, depending on cloud density and moisture content. The subtle differences reveal information about composition and altitude, visible to careful observation. You see transitions between day and night along the orbit. Sunrise and sunset appear compressed due to the speed of the station. Clouds shift in color from deep purples and blues to pale pinks and golds. The horizon glows softly before the sun emerges. Shadows stretch over the surface, moving quickly beneath the station. Clouds and direct light reveal textures invisible in darkness, the small peaks and valleys, the smooth layering, and the ragged edges shaped by wind. These transitions are continuous, graceful, and detailed, a constant display of change and movement. The station passes over different climates in a single orbit. Tropics, deserts, mountains, and polar regions all present unique cloud patterns. Tropical zones often have thick, rising clouds with defined tops. Deserts have thin, scattered clouds moving with dry air. Currents. Mountain ranges produce clouds shaped by elevation and wind, forming long lines along ridges. Polar regions show low, flat clouds moving over ice and snow, reflecting pale light from the surface. Observing these patterns gives insight into the connection between land, water, and air movement. You notice how storms interact with their surroundings. Air currents around mountains create ridges in clouds. Ocean currents influence the formation and alignment of cloud bands. Large weather systems move across continents, sometimes merging with other systems, sometimes dissipating slowly. Even small clouds drift apart or join together over time. From orbit, these processes are visible in a way impossible from the ground. You begin to sense patterns, the influence of temperature, pressure, and wind on cloud formation and movement, the interaction between atmosphere and terrain. The atmosphere itself appears layered. From your position, you can detect differences between the troposphere, stratosphere, and the thinner regions above. Clouds are mostly confined to the lower layers, yet their shapes and motion reveal wind currents at different altitudes. High clouds appear thin and stretched, often shaped by jet streams. Lower clouds are denser, sometimes blocking light from above or below. You notice how the thickness and altitude of clouds affect the appearance of storms and weather systems. The view emphasizes vertical structure as much as horizontal movement. Moonlight and starlight affect perception. On the night side, the soft reflection of the moon makes clouds visible even when city lights are distant. Ocean surfaces reflect light differently, making clouds above them stand out. Shadows created by cloud layers shift as the station moves, revealing gaps or ridges. At times, faint auroras add green and purple light near polar regions, highlighting the upper layers of the atmosphere. The interplay of natural light, cloud formation, and planetary rotation creates a continuous display of subtle color and movement. Weather patterns are clear from this altitude. Fronts, pressure systems, and wind corridors become visible in the shapes and directions of clouds. Storms move along predictable paths, but smaller systems can develop unexpectedly. You observe how the sun warms different surfaces differently, producing convection and rising clouds in some regions, while others remain calm. The details of cloud edges, density, and movement provide clues about temperature, humidity, and atmospheric pressure. Each orbit adds new information, a continuous lesson in weather science. Clouds are never still. Even during the night, they shift slightly, revealing the constant motion of air. You watch as isolated clouds slowly drift across land, breaking apart or merging with other clusters. Mountain shadows influence their shape. Coastlines shape the movement of sea clouds. Wind at higher altitudes tilts and stretches them. The observation creates a sense of time compressed into motion. You follow the journey of a cloud across several minutes, noticing how it evolves and interacts with its environment, gradually forming part of a larger pattern of atmospheric motion. The curvature of Earth adds perspective. You can see clouds receding toward the horizon, bending gently along the curve of the planet. Sunlight, when present, highlights layers differently at different angles. Even in darkness, the contrast between clouds and surface features becomes clear. City lights shine through thinner cloud layers, while thicker clouds appear as soft gray or white forms. Weather systems, storms, and isolated clouds all participate in a moving, layered tapestry. Observation becomes both scientific and meditative, a study of interaction between light, air, and water. Clouds reveal hidden details of geography. River valleys sometimes shape their alignment. Mountains create breaks and ridges. Large plains allow clouds to spread evenly. Ocean currents guide patterns across the surface. You notice subtle variations in color and density, sometimes indicating rain or wind, sometimes indicating dry conditions. Nighttime lights cast faint reflections, sometimes piercing thin cloud layers. Observation requires patient attention, following motion and noting subtle differences over time. Every orbit presents new perspectives, new patterns, and new insights. Auroras occasionally appear above cloud layers, especially near polar regions. Their colors and motion are enhanced by contrast with clouds below. Green, red, and purple waves ripple and fold across the sky. Their presence emphasizes the thinness and transparency of the upper atmosphere, revealing the interaction between Earth's magnetic field, solar wind, and air molecules. From orbit, you notice how auroras trace broad paths, shifting slowly but continuously, never fixed. Clouds below remain grounded, moving independently yet in harmony with the yet in larger dynamics of the planet. Storms continue their slow evolution. Lightning flashes inside clouds, revealing shapes and movement. Thundercloud tops cast shadows on lower layers, creating three-dimensional forms. You notice how storms grow, dissipate, or move with the larger flow of air currents. Isolated cells form and fade, while massive systems rotate slowly. Each movement is continuous, part of a larger pattern, yet each has unique structure and behavior. Observation allows understanding of scale, speed, and intensity, all visible from the station, in ways impossible from the surface. The transition of day and night is compressed. In a single orbit, sunrise or sunset occurs in minutes. Shadows lengthen and fade quickly. Clouds are highlighted differently with each change of light. The curvature of the horizon emphasizes shifts in shadow and color. You notice subtle gradients, from deep blues and purples to pale pinks and golds. Each shift provides new information about cloud, height, thickness, and composition. Observation becomes layered, combining time, light, and structure into continuous awareness. Even in darkness, patterns persist. Storms, cloud clusters, and weather fronts move steadily. Lights from human settlements illuminate the undersides of thinner clouds. Moonlight highlights the shapes of others. Ocean currents, coastlines, and mountains influence cloud formation subtly. Each orbit repeats the display, yet always with small variations. You follow these motions continuously, noticing change, direction, density, and interaction. Observation from above becomes a patient study of motion, light, and the atmosphere's endless flow. From the observation window, you look around the interior of the station and notice the structure itself. Pipes, cables, and panels line the walls, a complex network of machinery designed to keep life flowing. Air circulates constantly, moved by fans that hum softly in the background. You can feel the rhythm of the station, mechanical and steady, like the heartbeat of this orbiting laboratory. Each sound is familiar: the low vibration of pumps, the whir of motors adjusting equipment, the soft click of valves opening and closing. You begin to understand how each element contributes to life in space. Life support systems are the foundation of daily operations. They regulate oxygen, humidity, and temperature. You notice how the air remains consistent, neither too dry nor too warm. Fans gently move it around, preventing stagnant areas and keeping the environment safe. Carbon dioxide is removed automatically, and small sensors monitor levels continuously. Water is recycled and purified, flowing through tubes and containers unseen but essential. Even small leaks or clogs could become problems, so monitoring and maintenance are constant priorities. Each system functions silently, but without it, life in orbit would be impossible. Solar panels extend outward from the station's exterior. You imagine their size spanning tens of meters, angled to catch sunlight as the station moves. The panels pivot slowly, tracking the sun in precise motions. Energy is collected, stored, and distributed to systems inside. You notice that light from outside reflects faintly on the walls, showing the panel's position. Every adjustment is calculated. The balance of power is critical. The station cannot operate without electricity. Maintenance routines ensure that panels are clean, aligned, and functioning efficiently. Small errors could affect multiple systems, so precision is constant. Docking ports allow vehicles to attach to the station. You imagine capsules or supply ships connecting to these ports, their approach carefully monitored. Latches engage automatically, creating airtight seals. Each docking requires checks of pressure, communication, and alignment. You sense the careful choreography needed for these operations. Even minor misalignment could be dangerous. Observing from inside, the station feels alive, ready to receive or release equipment, materials, or people. These ports are gateways to and from Earth, vital to the station's operation. External modules are visible through windows and cameras. Laboratory modules, living quarters, storage sections, all arranged to maximize space, function, and safety. You notice the design considerations: pathways for air, tubing for water and gases, and attachment points for experiments. Each module serves a purpose, whether scientific, technical, or human comfort. The station's architecture is functional, designed to be efficient in zero gravity. You imagine how each module is connected, how crew move through narrow passageways, floating between sections while performing tasks or moving supplies. Mechanical sounds are constant but unobtrusive. Fans hum in rhythm with pumps, motors, and compressors. The sound of water moving through pipes can be faintly heard, a gentle reminder that systems are active. Valves open and close quietly. Occasionally, a small click or thrum punctuates the background, marking an adjustment, a monitoring action, or a cycle completion. The combined soundscape is subtle, yet constant. You realize that crew members adapt quickly, recognizing each sound as an indicator of system status, normal operation, or a warning to attend more closely. Daily operations are choreographed carefully. Each movement is deliberate. You imagine crew members moving from module to module, using handrails and footholds, carrying equipment, checking instruments, and recording data. Every action follows protocols, routines designed to prevent errors and ensure safety. Even small tasks are performed with attention, securing a loose panel, confirming readings on a sensor, or verifying the alignment of a solar panel. Life in orbit requires constant vigilance and precision. Maintenance tasks are routine but essential. Filters are checked and replaced. Sensors are calibrated. Mechanical arms are tested, joints lubricated, and software systems updated. Crew members float to equipment, gripping rails, guiding tools, and observing outcomes. Every system has a backup, but attention to detail ensures that backups are rarely needed. Observation and interaction are continuous. Each crew member learns to anticipate the needs of the station and respond to small changes before they become problems. Safety is paramount. Emergency protocols are rehearsed and ready. Fire suppression systems, oxygen masks, and communication lines are constantly monitored. You imagine the careful design of escape paths, emergency hatches, and pressure seals. Even a small failure could have serious consequences, So every procedure is practiced, every sensor checked, and every connection verified. The presence of these systems allows life to continue in a controlled environment, giving both comfort and awareness to the crew. Human experience in the station is unique. You move slowly along corridors, noting the tactile feel of handrails, the spacing of modules, and the use of Velcro or straps to secure objects. Simple actions require new techniques. Floating while carrying equipment demands coordination. Eating, drinking, and writing are modified to work safely in microgravity. Every motion, no matter how small, is informed by experience, observation, and constant adjustment. Daily life blends science, routine, and awareness in a delicate balance. Electrical systems are monitored constantly, and panels show energy usage, distribution, and storage. Crew watch for fluctuations, ensuring that critical systems have power. Batteries, converters, and circuits are part of a network designed to prevent loss of function. Even a momentary drop could affect life support, communications, or scientific experiments. Observation of readings, attention to detail, and small adjustments keep the station stable. Electrical stability underpins all other operations and is observed continuously by crew and automated systems alike. The station's exterior requires attention too. Modules connected in space must be inspected. Cameras allow monitoring of joint areas, thermal panels, and shielding from micrometeoroids. Occasionally, a spacewalk is needed to replace or repair an external component. These operations are highly controlled, with careful preparation and tethering and coordination. From inside, you can follow each movement and see how the design supports safety and functionality. The choreography of human and machine is evident even without leaving the interior. Communication systems maintain contact with Earth. You notice the small delays, the way signals travel from orbit, bounce through satellites, and reach mission control. Every command and response is monitored. Alerts, updates, and instructions are received in real time, guiding operations. Data from sensors, experiments, and observation points is transmitted continuously, analyzed, and stored. The station functions as both a home and a laboratory, connected in ways invisible but essential to its operation. Temperature and pressure are stabilized by automated systems. Sensors detect minute changes, adjusting valves and fans to maintain consistent conditions. The cabin remains comfortable for humans, yet every change is observed closely. Microgravity makes heat transfer different, requiring careful monitoring. Even small fluctuations are noted, adjusted, and corrected to ensure safety. Awareness of these processes provides insight into how finely tuned the station systems must be to support life. Every movement inside the station has a purpose. Tools are organized for easy access. Cables and tubing are clearly labeled. Panels are opened only when needed, minimizing the risk of accidental contact. Crew become familiar with each module's layout, the location of controls, and the sounds of normal operation. Observation of patterns allows anticipation of potential issues. There is a rhythm to life here. Work, observation, maintenance, and rest, all balanced to keep the station functioning smoothly. The interplay between human and machine is continuous. Crew members rely on automated systems but maintain oversight. Manual adjustments complement automated cycles. Observation, recording, and minor intervention maintain stability. Every day is an exercise in attention, coordination, and careful action. The station, though designed for safety, requires human presence, insight, and response to function at peak efficiency. The collaboration between engineering, life support, and crew is seamless yet demanding. You notice the small details that make life possible: latches that click securely, valves that move smoothly, and tubes that carry water silently, screens that display readings in real time. Each piece contributes to a larger system, ensuring life, observation, and research continue without interruption. The complexity of the station is evident, but so is its order, as every system is integrated, each action purposeful, and by each element carefully maintained to support continuous life in orbit. From this perspective, the station is not just a laboratory or home, it is a precise ecosystem. Human presence, machinery, and scientific purpose coexist. The hum of equipment, the soft ventilation, the organized modules that in the controlled lighting all combine to create an environment where life can thrive. Observation, as attention to detail, and constant care transform complex engineering into a habitat that functions naturally once routines are established. Life here becomes both predictable and fascinating, a balance between technical precision and human adaptability. Even simple movements are informed by engineering. You pull yourself along a handrail, knowing the layout of modules. You handle tools carefully, aware of sharp edges, electrical contacts, and moving parts. You adjust controls with understanding of their effect. Small errors are avoided through observation, repeated practice, and careful attention. Each task, from food preparation to experiment monitoring, integrates seamlessly into the station's operations, reinforcing the importance of awareness, patience, and precision. Life in orbit combines daily routine, careful attention, and continuous observation. Crew members float through corridors, check instruments, monitor life support, adjust panels, and follow protocols. Systems hum, fans circulate air, pumps move water, and lights indicate status. The station functions smoothly because of the integration of human effort and engineering design. Observation from inside reveals the quiet choreography of daily operations, the continuous work that supports life, research, and observation from orbit. Every action, small or large, contributes to a functional, safe, and precise environment that allows humans to live above Earth for extended periods. From the observation window, you watch Earth unfold beneath you, oceans stretch out in every direction, deep blue and endless. Waves are too small to see individually, but the surface is never still. Light glints off ripples, and subtle currents create darker and lighter shades that shift with time. You notice patterns where water meets wind, small streaks and eddies forming faint lines that trace the motion of currents. From above, the ocean feels vast, almost infinite, yet its movement is gentle and constant. Even as the station moves quickly, the water below flows at its own pace, obeying the invisible forces that shape it. Coastlines emerge gradually as the station passes overhead. Sandy beaches, rocky cliffs, and river mouths become visible, outlined by the contrast between land and water. Each coastline has a distinct shape, carved by waves, tides, and erosion. You can see how rivers feed into the oceans, leaving deltas with patterns of branching channels. In some regions, sediment changes the color of the water near shore, producing subtle shifts from deep blue to green or brown. The contrast between shallow and deep water creates natural textures, visible from orbit as soft gradients that trace the land beneath. Deserts appear as broad, empty expanses. Sand reflects sunlight differently than rock or vegetation. You notice ridges, dunes, and occasional rock formations. Shadows fall across the surface, creating lines and curves that reveal the terrain's subtle variations. From above, you can see how wind shapes the desert landscape, forming patterns that repeat over large distances. During night passes, desert temperatures affect cloud formation slightly, and occasional thin clouds drift above. The interaction between land, atmosphere, and the sun's heat becomes evident when observing deserts over multiple orbits. Forests cover large stretches of land. Dense tree cover forms darker textures, contrasting with deserts and grasslands and urban areas. You notice variations in color, from deep green to lighter shades, indicating different types of vegetation and seasonal changes. Shadows from clouds above move across the canopy, creating soft, shifting patterns. You see rivers and streams threading through forests, their paths visible as thin, reflective lines. The scale of forested regions emphasizes how interconnected ecosystems are and how weather, water, and light interact to shape the environment continuously. The station moves quickly along its orbit. Even as continents and oceans pass below, the motion is smooth. Within minutes, landscapes change. Mountains give way to plains, deserts fade into forests, and rivers meander into the sea. Day and night cycles appear compressed. Sunlight strikes clouds and surfaces at different angles, revealing textures that are hidden in shadow. You notice how the angle of light highlights topography, wave patterns, and the subtle movement of water. Observing continuously, you develop a sense of timing, the rotation of the planet, the speed of orbit, and the sequence of changing landscapes. Atmospheric effects are always present. Thin clouds drift above oceans and continents. They create shadows, diffuse light, and sometimes obscure details below. Humidity affects the thickness and form of clouds. You notice the haze over large rivers or urban areas. Faint mist can appear over oceans in the early morning, creating subtle reflections. Shadows shift with wind and sun, moving slowly yet noticeably. The atmosphere interacts with surface features, forming patterns that you can follow as the station passes from one region to another. You see the reflection of sunlight on water. Waves create flickers of brightness that move continuously. Coastal shallows reflect differently than deep ocean areas, producing gradients of color. Even small islands stand out due to light reflection. Patterns of wind over the water surface create subtle streaks. You observe the difference between calm and turbulent regions. Storm clouds above water create shadows and contrast. Lightning flashes occasionally illuminate the sea briefly, providing insight into storm intensity and cloud structure. The interaction between water, light, and atmosphere is constant, changing with each moment. Rivers stand out as veins of reflection through land. Their courses often mirror human settlements nearby. You notice how water flows from mountains to plains, carving valleys and shaping the surrounding terrain. River mouths create patterns of sediment spreading into the oceans, altering water color. From orbit, these flows appear slow yet constant, a reminder of the persistent work of water shaping the land. Small lakes and reservoirs are visible as calm patches, reflecting sunlight and cloud shadows. Even subtle changes in water level or clarity are perceptible with careful observation. Clouds continue to move across landscapes. Their motion is independent of the station, but influenced by underlying geography and weather systems. You notice that clouds over oceans often form lines and streaks shaped by wind patterns. Over mountains, clouds gather into ridges and peaks. Across plains, they drift freely, forming soft shapes. The interplay between clouds and surface features creates patterns of light and shadow that highlight topography, water, and human influence. Even night passes reveal faint cloud outlines against city lights or moonlit surfaces. Coastlines and islands reveal subtle textures. Beaches, reefs, and shoals sometimes appear as faint lines in shallow water. Rocky cliffs cast shadows that reveal vertical relief. You notice tidal flats and sandbars during low tide, their shapes visible from orbit. Waves and surf interact with these features, creating constantly changing patterns. Coastal storms generate swirls and foamy patches on the ocean surface. The interplay between land and sea is dynamic, showing continuous interaction between water, geology, and atmospheric forces. Mountains provide contrast and variation. Snow-capped peaks reflect sunlight brightly, while valleys appear darker in shadow. Wind currents interact with mountains, shaping clouds into ridges or waves. You can see how rivers originate in highlands, carving paths through terrain before reaching plains and oceans. Observation reveals the scale of mountains, their impact on climate, and the influence they have on cloud formation. Each range has unique textures, visible in light and shadow, revealing topography and geological history in broad strokes. Forests continue to form patterns. You notice the difference between dense tropical regions and more open temperate forests. Rivers cut through these regions, creating meanders and oxbow lakes. Seasonal changes affect color, with subtle shifts in green and brown visible over time. Fires or deforested areas appear as dark patches. You can track the boundaries of human activity versus natural growth. Observation emphasizes the interconnectedness of vegetation, water, and terrain, and the way these systems interact with weather and light. The station's orbit allows multiple passes over the same regions. You notice changes with each pass. Shadows lengthen or shorten depending on the sun's angle. Cloud formations evolve. Water surfaces shimmer differently under sunlight or moonlight. Even ocean currents create visible changes in wave patterns or foam. Observation over time reveals movement, rhythm, and continuity in Earth's systems. From orbit, these cycles are compressed, allowing you to perceive changes that might take hours or days from the surface. Islands appear as small oases in oceans. Their coastlines are distinct, often lined with coral reefs or sandy beaches. Vegetation covers the interior, sometimes dense and sometimes sparse. From orbit, you notice their shape, elevation, and proximity to other land masses. Light reflecting from water around islands emphasizes shallow areas. Small settlements, if present, appear as faint lights at night. Observation provides some insight into both natural and human-made features, a mixture of geography, ecology, and settlement patterns. Desert transitions into mountains or plains show distinct changes in texture and color. Sandy surfaces shift to rock outcrops or vegetation as the terrain changes. Shadows emphasize ridges, valleys, and plateaus. Even small changes in topography influence cloud formation and wind flow, creating visible patterns. You notice subtle differences between regions, revealing how geography shapes both land and atmosphere. Observation requires patience, following lines of contrast, color, and motion to interpret the landscape beneath. The ocean's surface is never uniform. Currents, temperature gradients, and wind patterns create subtle movement visible from orbit. You notice variations in color, from deep blue to lighter shades near coastlines or shallow areas. Storms on the horizon create white caps and foamy patches. Small cloud shadows move across the water, emphasizing the texture and flow of waves. Observation of these details shows how interconnected atmosphere and ocean are, how light interacts with surface features, and how motion is continuous yet subtle. Rivers, valleys, and plains all interact with clouds and sunlight. Shadows cast by clouds highlight terrain features. Light reflects off water and snow differently than land. These contrasts create a layered effect visible from orbit, showing texture, shape, and color variations. Even subtle atmospheric effects like haze or humidity influence visibility. Observation from the station provides a continuous, dynamic perspective on how land, water, and air interact across the planet. You follow long stretches of coastline as the station moves. Beaches, cliffs, and estuaries pass beneath quickly. The curvature of Earth becomes evident. Oceans and continents bend gently along the horizon. You notice changes in light and color as the sun or moon illuminates different angles. Water reflects sunlight or moonlight, while clouds create shadows that sweep across land and sea. Patterns repeat, yet remain unique in each moment. Observation becomes both visual and temporal, a study of motion, contrast, and scale across the planet. You sense the passage of time through these views. Each orbit compresses hours into minutes. Movement of clouds, water, and land beneath is continuous. Cities and rivers trace patterns of human activity. Deserts shift slowly with shadows. Storms evolve, forming and dissipating. Ocean currents continue their subtle flow. Even night reveals activity. City lights, ships, auroras, and faint reflections on water. Observation is continuous, immersive, and attentive, a careful study of Earth's surface and motion as the station travels overhead. As the station approaches the polar regions, the view of Earth changes. Darkness stretches across the landscape, yet light begins to appear in slow, shifting patterns near the poles. These are auroras, soft glows dancing across the atmosphere. From orbit, they are broad and fluid, moving gently across the sky. The colors are subtle but distinct: pale green waves, soft red streaks, occasional hints of violet. They shift slowly, folding over one another, rising and fading in a continuous, flowing motion. Observing from this height, the auroras appear less like small lights and more like the breath of the planet itself. You begin to understand why auroras form. Charged particles from the sun travel along invisible lines, guided by Earth's magnetic field. They collide with molecules in the upper atmosphere, causing them to emit light. The effect is visible as these slow-moving ribbons, curtains, and arcs. From orbit, the scale is immense. What appears from the surface as a narrow streak expands into broad sheets of color, spanning hundreds of kilometers. You can see variations in intensity as different regions light up, then fade, in response to solar activity. The colors change with altitude and composition. Green is most common, produced by oxygen molecules around 100 kilometers above the surface. Red hues appear higher, above 200 kilometers, often in faint bands that stretch across the horizon. Violet and purple appear occasionally, created by nitrogen. The layering of colors adds depth, creating a three-dimensional effect when viewed from above. The subtle shifts in color are continuous, blending from one to another without abrupt transitions, revealing the structure of the atmosphere in motion. Auroras interact with the landscape below. Over oceans, the glow reflects faintly on water, adding a mirror effect that emphasizes movement. Over ice and snow, light spreads across the surface, brightening the scene gently. You notice how shadows cast by clouds alter the view, creating contrast with illuminated areas. The effect is always in motion, never static. Even when stationary, the aurora seems alive, responding to the flow of particles and the invisible lines of Earth's magnetic field. The magnetic field itself is invisible, but its presence is revealed in these phenomena. Lines converge at the poles, guiding solar wind particles along paths that make light visible. Storms of charged particles from the sun create stronger auroral activity, forming brighter and more complex displays. From orbit, you can observe how these displays are distributed over the northern and southern hemispheres, forming mirrored shapes, yet each region has unique details. You sense the protective role of the magnetosphere, shielding Earth from energetic particles while creating these visual effects. Movement is continuous and subtle. Curtains of light ripple as if stirred by invisible currents. Bands rise and fall, fold over themselves, and drift slowly across the polar sky. Sometimes arcs stretch from horizon to horizon. Occasionally, pulses appear, brightening parts of the aurora before fading. The motion is slow enough to observe closely, yet continuous enough to emphasize the energy and constant flow of particles in the upper atmosphere. Watching for several minutes reveals patterns that repeat, yet always slightly different as solar wind conditions change. The light interacts with the upper atmosphere. Oxygen and nitrogen molecules glow when struck, producing color and movement. From orbit, you can see how the thickness of the atmosphere affects brightness. Denser regions emit more light. At night, the aurora stands out sharply against the darkness of space. At times, faint clouds below diffuse the light, creating softer effects. Observation requires attention to both the aurora itself and the context of the surrounding atmosphere, clouds, and surface features. The interplay is delicate, constantly shifting, and perceptible in detail from above. Storms in space influence auroral activity. Solar flares and coronal mass ejections send streams of charged particles toward Earth. When they reach the magnetosphere, auroras intensify. You can observe brighter flashes, broader arcs, and more vibrant colors. Even minor changes in particle density affect the display, producing subtle ripples and folds. From orbit, the reaction of Earth's atmosphere to the Sun's activity is continuous, a dynamic connection between space and planet. The patterns of light are not random. They follow invisible physical forces shaped by the magnetosphere. Auroral shapes are diverse. Bands, curtains, spirals, and arcs appear in sequence or simultaneously. You notice how one band can rise above another, fade, and be replaced by a different structure. Motion is smooth, yet complex. Layers form naturally, influenced by particle density, magnetic field strength, and altitude. From orbit, you can track individual structures, following their movement across hundreds of kilometers. The scale of motion becomes clear, emphasizing how the upper atmosphere responds to energy and magnetic guidance. You observe the poles themselves. Ice, sheets, and snow reflect faint light, adding contrast to the auroral colors. Mountainous polar terrain appears dim, with shadows stretching under the soft glow. Clouds occasionally pass, altering visibility. Even subtle shifts in wind or temperature at high altitude create small changes in the aurora's appearance. Observation from orbit provides continuous, uninterrupted views, showing the interaction between magnetosphere, solar wind, and atmospheric particles in a way impossible from the ground. Auroras are affected by both hemispheres' conditions. In the north, shapes follow magnetic lines that curve toward the Arctic. In the south, patterns mirror the north, yet differences appear due to local atmospheric density and geomagnetic configuration. From orbit, the symmetry and variation are observable at once. Solar wind activity affects both regions simultaneously, but the precise manifestation is unique in each hemisphere. You can see the interplay of global forces shaping local effects in real time, a slow yet perceptible dance of light and energy. Light intensity varies gradually. Bright pulses appear in some areas, while other regions glow faintly. Shifts in solar wind pressure can change brightness over minutes. You notice how colors deepen or fade with altitude and time. Green dominates lower layers, red at higher layers, occasionally violet along edges. The aurora's continuous motion ensures that colors blend and change constantly. Watching for long periods reveals the complexity of interactions between atmosphere, magnetic fields, and incoming solar particles. You notice patterns forming over oceans and ice. Arcs stretch along lines defined by the magnetosphere. Spirals rotate slowly. Curtains ripple as particles interact with molecular layers. The motion is soft and steady, yet intricate. Each change is small, but together they form dynamic displays that evolve continuously. Observation emphasizes patience and attention. Subtle motions become visible, revealing interactions invisible from the surface. From orbit, the aurora is an open book of physics, light, and atmospheric response. Sometimes, faint green bands appear near the horizon. They rise and fade gradually, moving slowly across your field of view. Red edges can form above, creating layering and depth. Purple edges are rare but striking when visible. The folding motion of light creates a curtain effect, which can stretch for hundreds of kilometers. Observation allows you to track the motion, noting how the aurora responds to changes in magnetic field strength, particle flux, and atmospheric density. Continuous watching reveals patterns that are invisible from below. The interplay with clouds and atmospheric layers is subtle. Thin, high altitude clouds can partially obscure light, creating diffused glows. Lower clouds cast shadows, adding contrast. Even when no clouds are present, air density variations affect color and brightness. Observation requires careful attention to subtle differences. The aurora's motion and color are influenced by multiple factors simultaneously: particle flux, magnetic field, altitude, atmospheric composition, and background lighting from Earth's surface. From orbit, these factors are all visible together. You can sense the scale of auroral phenomena. What seems narrow from the surface expands into wide bands and sheets from above. Some arcs stretch across thousands of kilometers, moving slowly yet continuously. Even small ripples are noticeable when observed for several minutes. The height of emission layers adds depth. Variation in intensity, color, and shape emphasizes that the aurora is not a single phenomenon, but a continuous, multi-layered process. Observation combines spatial and temporal awareness to appreciate its complexity. The aurora highlights the connection between Earth and the Sun. Solar wind, invisible to the eye, shapes the motion and color. Energy from distant eruptions arrives and interacts with the planet's magnetic shield. Observation from orbit reveals both the effect and the cause simultaneously. You see the protective function of the magnetosphere, guiding particles along lines, dissipating energy, and producing visible light as a byproduct. The relationship between sun and planet is direct, continuous, and perceivable over minutes and hours of observation. Auroral activity changes over time. Storms intensify or fade, patterns shift gradually. You notice sequences where bands rise, fold, and disappear. Pulses propagate along arcs, revealing motion that is smooth yet deliberate. Color changes are gradual, with green, red, and violet blending seamlessly. Observation encourages attention, patience, and awareness of subtle change. Even without direct interaction, the aurora teaches the structure, rhythm, and energy of Earth's magnetosphere and upper atmosphere. You observe these phenomena repeatedly from orbit. Each pass offers variations, different intensity, structure, and motion. Even familiar shapes appear new, influenced by atmospheric conditions, magnetic changes, and solar wind activity. Watching continuously allows you to detect slow evolution, subtle gradients, and rhythmic shifts. The aurora is always in motion, never static, providing endless opportunity for observation, reflection, and quiet study of planetary processes from a unique vantage point. Even at night, light from human settlements occasionally glimmers faintly through thin cloud layers below. The aurora above contrasts with these points, emphasizing the natural versus human-made sources of illumination. From orbit, the perspective allows simultaneous observation of auroral light, clouds, ocean, ice, and land, creating a layered view of Earth's surface, atmosphere, and magnetic environment. Observation is immersive, detailed, and continuous, highlighting both scale and subtlety. Watching auroras encourages a patient, meditative focus. Slow changes, flowing patterns, and subtle color shifts reveal the invisible forces shaping the atmosphere. Motion is continuous and uninterrupted. Light folds, waves, and arcs across the horizon. Interaction with particles, fields, and atmospheric layers is evident. Observation becomes a combination of science and sensory awareness. You track motion, note color, and understand scale, all while appreciating the continuous choreography of geomagnetic phenomena from orbit. From the station's observation window, you notice how quickly the world below changes. Morning becomes night in the span of minutes. You watch the sun rise along the horizon, painting oceans, mountains, and plains with shifting light. The colors are gentle at first, pale pink and soft gold, then intensifying into warmer tones. Minutes later, darkness spreads again, covering regions in shadow. The movement is fast compared to life on Earth. Cities, forests, deserts, and oceans pass beneath in a sequence that feels continuous yet accelerated. You start to sense the rhythm of orbit, a cycle repeated with quiet precision every 90 minutes. The station's orbit allows you to witness multiple sunrises and sunsets in a single day. You watch the sun climb above clouds, reflecting off water, illuminating deserts, and casting long shadows over mountains. Each sunrise has subtle differences. The angle changes slightly with each orbit, revealing new details. Clouds scatter light, oceans shimmer differently, and the curvature of the planet becomes noticeable. These repeated cycles create a unique perception of time. Hours on Earth condense into a fraction of your experience here. You become aware of how motion and speed alter your sense of duration. Sunsets are equally captivating. Light fades gradually across continents, oceans, and forests. Shadows lengthen and colors deepen. You notice the red and orange gradients along the horizon, softening as the sun disappears. The transition is smooth, yet swift, revealing the planet in successive layers. Observing repeatedly, you begin to anticipate the motion of the sun and the subtle changes it brings. Patterns emerge, the way clouds reflect light, how the ocean mirrors the sky, and the gentle darkening of deserts and mountains. Each orbit creates a predictable yet ever changing spectacle. You feel the speed of the station keenly. Traveling at over 27,000 kilometers per hour, the Earth below moves past quickly, yet from inside, the motion feels calm. Objects float without resistance, and the station's internal rhythm is steady. The rapid orbit contrasts with the slow pace of observation outside. You watch large rivers snake through landscapes, deserts expand, and mountain ranges pass, all within moments. Despite speed, there is continuity. The movement allows you to trace connections between clouds, rivers, coastlines, and forests, noticing how the planet's surface changes gradually yet appears compressed in time. Time perception shifts in this environment. Familiar markers, sunrise, sunset, day, and night, occur repeatedly in orbit, compressing the normal rhythm of life. You experience multiple cycles in what would be a few hours on Earth. The repetition allows close observation of environmental changes that might take days from the ground. Cloud patterns evolve, city lights turn on and off, and ocean surfaces reflect light differently on successive passes. Your awareness of time becomes tied to motion rather than clocks. Each orbit reinforces the connection between speed, rotation, and human perception. The curvature of Earth is visible during these cycles. As the station moves, horizons curve gently away. Sunlight spreads along these curves, producing gradual transitions between illuminated and shadowed regions. Oceans seem to bend toward the horizon. Mountains and plains follow, emphasizing the planet's roundness. The sun appears to rise and fall more quickly, yet the effect is gentle. Shadows move in response, lengthening, shortening, and sweeping across landscapes below. Observation of this curvature ties together motion, light, and perception of time. Night follows day repeatedly, compressed in orbital rhythm. Cities light up, casting faint glows visible from above. The contrast with natural landscapes emphasizes human presence. Rivers, roads, and coastlines reflect artificial illumination. From orbit, you can trace patterns of civilization as small lights shimmer across continents. Observation highlights the difference between day and night, natural and artificial illumination. Each orbit provides both repetition and variation, giving insight into how Earth changes in light, texture, and motion over time. You become aware of atmospheric effects in relation to the orbit. Clouds drift slowly compared to the station's speed, yet their movement is noticeable. Storm systems rotate, forming spiral patterns. Shadows shift as light angles change. Sunlight scatters in the upper atmosphere, producing soft gradients at sunrise and sunset. Light is reflected, refracted, and absorbed differently depending on altitude and composition. You notice haze, thin clouds, and fog across landscapes. Observation of these effects teaches the influence of atmosphere on light, motion, and perception of time. Observing oceans emphasizes the station's speed. Waves ripple continuously, reflecting sunlight in flickers. Currents form darker and lighter shades that move slowly beneath. Clouds cast shadows that drift across surfaces. From orbit, you see large scale motion that is imperceptible from the ground. The repetition of sunrises and sunsets accelerates observation of patterns. You trace rivers, shorelines, and currents in ways impossible from a stationary perspective. Motion as in time intertwine, creating a continuous study of landscape, water, and light in rapid sequence. Cloud formations change with each orbit. Patterns form, evolve, and dissipate in minutes. Storm systems shift. Gentle clouds drift over oceans, mountains, and deserts. Observation is continuous, requiring attention to motion, scale, and timing. Small changes are perceptible over repeated passes. Even faint features, like fog over a river delta or low cloud cover over a forest, can be followed. Your sense of time becomes linked to these changes rather than traditional measures. Minutes reveal dynamics that are hours or days on Earth. Sunlight interacts with surface features differently in each orbit. Reflections off water, snow, or sand vary. Shadows lengthen, shorten, and sweep across mountains and plains. Vegetation and urban areas react to light in subtle ways. Even deserts show gradual changes in shading. The orbit compresses these changes, offering a continuous observation of environmental variation. Repeated cycles create a rhythm of light, shadow, and color, linking perception of time to motion around the planet. You notice the atmosphere's role in perception of time, as haze, cloud, cover, and air density subtly alter the speed at which light changes across landscapes. Shadows move differently depending on cloud thickness. Light scattering produces gradients that slowly evolve. Observation from orbit highlights these subtle changes. The repetition of sunrise and sunset cycles accentuates the contrast between rapid motion of the station and slower dynamics of the atmosphere below. The orbit reveals long-scale patterns. Mountain ranges, rivers, and deserts form continuous structures that pass beneath the station rapidly. Each orbit compresses large distances into a few minutes of observation. You notice how features align with sun and shadow, producing consistent visual cues. The speed of travel emphasizes Earth's scale. Observation requires attention, patience, and continuous focus to track changes over time. You sense the rhythm of planetary rotation and orbital motion simultaneously. You track large weather systems in repeated orbits. Storms rotate, clouds swirl, and light reflects variably. Night passes reveal lightning flashes within storms. Daylight reveals shadowed topography below. These repeated observations that teach the timing of atmospheric motion relative to orbital speed. Subtle changes in cloud density, storm formation, or snow cover become noticeable. The compression of time allows detailed study of dynamics that would take days from a surface perspective. The station's speed affects perception of motion. Oceans, continents, and deserts pass beneath rapidly. Light and shadow sweep across surfaces. Clouds drift more slowly, providing reference points. Mountains, forests, and rivers seem to move under a moving frame. Observation becomes a study of relative motion, linking orbital mechanics to human perception. Each orbit provides new combinations of light, landscape, and atmospheric effects. Time is experienced differently in space, tied to movement, Rather than conventional clocks, you feel the passage of days differently. Passage of sunrise and sunset occur multiple times in Earth hours, yet the human rhythm inside the station remains constant. Meals, experiments, maintenance, and rest continue according to schedules, but outside, time compresses. The repetition of orbital cycles provides a perspective on the planet's rotation and revolution, and on the continuous flow of sunlight, shadow, and night. Observation and reflection reveal both the speed of motion and its impact on perception. Nighttime observation allows tracing human influence. Lights from cities, roads, and settlements shimmer faintly. Repeated passes reveal patterns of habitation, urban growth, and transport networks. The orbit compresses what would be hours of change into minutes of view. Observing city lights alongside natural landscapes emphasizes differences in scale, pattern, and timing. Repetition of cycles enhances awareness of both natural and human rhythms from orbit. You notice subtle changes in color and brightness across the planet. Sunlight hits snow differently, water reflects variable intensities, and cloud shadows evolve. These gradual changes become apparent over multiple orbits. Observation combines awareness of light, motion, and scale. Each pass reinforces knowledge of Earth's rotation, orbit, and the movement of atmospheric and surface features. The perception of time is intertwined with observation of motion from the station. The orbit compresses motion and perception. Days, nights, sunrises, and sunsets repeat in accelerated rhythm. Landscape, weather, and human settlements pass below in a continuous flow. Observation from this vantage reveals patterns in natural and human systems, showing connections between movement, light, and time. Awareness expands as you track multiple cycles, noticing the pace of change and the relative stillness within the station. Perception is informed both by speed and continuity. Repeated orbits teach rhythm. Clouds form and fade, rivers reflect light, and landscapes pass beneath. Sun rises and sets multiple times, showing subtle differences each cycle. Shadows lengthen and shorten. Night brings city lights and moonlight reflections. Observation trains attention to motion and timing, linking human experience of time to the continuous movement of the station above Earth. You sense continuity, pattern, and subtle variation, a slow, immersive understanding of orbital motion and its effect on perception. As you turn your gaze away from Earth, the universe opens up in a vast panorama. Stars scatter across the blackness of space, countless points of light stretching to the edges of perception. The Milky Way appears as a broad, pale river of stars, faintly glowing and subtly textured. From orbit, it is more defined than on Earth, unblurred by atmosphere. You notice individual clusters, faint nebulae, and variations in brightness across the band. The view is constant yet filled with gentle motion as Earth orbits and the station carries you along a curved path around the planet. Planets occasionally appear in the field of view. Their light is steadier than that of stars, subtle yet noticeable. You can distinguish colors. Venus shines with a soft, pale white. Mars shows a faint reddish tint. Jupiter and Saturn appear as bright, slightly yellowish points. The relative positions of planets change slowly, detectable over hours or days. Observing them from orbit, you perceive their movement against the more distant fixed stars. Subtle parallax occurs even over a single orbit as your viewpoint shifts, revealing small differences in apparent positions. This shifting perspective emphasizes that Earth is part of a larger system, moving along paths defined by gravity and motion. Satellites pass occasionally, small and fast, moving along predictable arcs. They reflect sunlight briefly, appearing as tiny streaks across the sky. You notice how these man-made objects contrast with the distant stars, moving rapidly, blinking faintly, precise in motion. Observation emphasizes both the scale of human activity in space and the immensity of the cosmic background. Even the fastest satellites move slowly relative to the vast distances separating stars and galaxies. Awareness of scale expands, blending human presence with the quiet, immense backdrop of the universe. Constellations are visible in ways different from Earth. Without atmosphere, light is sharper, and more stars become visible. Patterns familiar from Earth's surface appear with subtle changes in alignment. As the station orbits, constellations shift slightly from orbit to orbit. You notice parallax, small apparent changes in position caused by the movement of your viewpoint around Earth. The same stars appear in different places relative to one another, emphasizing the three-dimensional nature of space. Observation becomes both scientific and contemplative, a study of perspective and distance in a living cosmos. The station's movement highlights Earth as a reference point. Against the starry background, the planet rotates, continents and oceans subtly changing position. Nighttime lights shimmer across inhabited areas. Clouds drift slowly, shadows form and fade. From orbit, Earth is a luminous, dynamic object suspended in blackness. Observation reminds you that your home exists within a larger environment, moving constantly through space. The planet rotates, revolves, and carries life along with it, all while the universe continues its vast, slow motion beyond. Moonlight adds subtle illumination. Reflections on clouds and water provide soft glows, faintly brightening regions otherwise dark. The lunar surface itself is visible, detailed and textured against the black sky. You notice craters and subtle shading, the interplay of light and shadow creating depth. Observation of the moon reinforces the sense of motion. Tides respond to its pull, illumination changes over time, and orbital alignment shifts slightly each night. These subtle cycles connect Earth and its satellite in a continuous gravitational and visual dialogue. The Milky Way's texture becomes more apparent as the station moves. Dense regions reveal clusters and dust lanes. Bright patches mark star-forming regions. Faint, dark streaks indicate interstellar matter. Observation requires careful attention, noticing differences in brightness, color, and density. Each shift in perspective as the station orbits provides a new view. Movement across the planet creates an evolving frame against which these structures can be appreciated. The continuity of observation shows both the immensity and intricacy of the galaxy, emphasizing that Earth is one small part of a larger whole. Distant stars appear stable yet varied. Some twinkle faintly due to subtle atmospheric interference from reflections off Earth below, though the majority remain steady. Their color varies subtly: blues, whites, yellows, and reds. Observation over hours shows no perceptible motion against more distant stars. Patterns repeat night after night, yet you can detect small changes caused by orbital motion or relative parallax. The field of view creates a backdrop that is constant yet filled with detail, providing a frame for observing Earth, Moon, and other celestial objects in context. The sense of scale is striking. Earth, oceans, continents, and clouds appear small in comparison to the vast stretches of space. Stars, galaxies, and nebulae extend far beyond immediate perception. Observation encourages a slow, reflective awareness of position and movement. You note the continuous motion of Earth below, orbiting the Sun, while the universe beyond holds immense distances. The station becomes a bridge between these scales, a vantage point to experience motion, size, and distance simultaneously. Occasionally, meteors or small atmospheric phenomena become visible. Streaks of light cross the horizon briefly. They appear fast yet small, contrasting with the slow movement of constellations and the sweeping rotation of Earth. Observation reinforces the variety of motion in the universe: fast and brief, slow and continuous, distant and immediate. Awareness of these differences trains perception and patience, allowing both scientific understanding and sensory immersion. Observation is also emotional and reflective. Seeing Earth in orbit, surrounded by stars and cosmic structures, emphasizes home. Familiar continents, oceans, and city lights appear delicate against the vast moving universe. The perspective encourages quiet reflection on human scale, the fragility of life, and the connectedness of planetary systems. Observation is not merely visual, it is grounding, sensory, and contemplative. Each orbit brings both factual data and subtle emotional insight into the place of Earth in the cosmos. Motion of satellites, planets, and distant objects illustrates time and scale. Each orbit compresses events that are slow on cosmic scales into moments perceptible from the station. Parallax effects reveal distance, planetary positions shift subtly, arcs trace orbital paths, and stars show apparent motion against background galaxies. Observation combines immediate sensory input with awareness of long-term celestial mechanics. You see time both compressed and expanded, dependent on reference frame and motion. The cosmic context deepens awareness of the planet's fragility. Earth rotates beneath you, a living, breathing sphere with weather, oceans, and life. Beyond, stars shine steadily, galaxies extend endlessly, and motion is continuous yet imperceptible from the surface. Observation bridges these scales, tying the immediacy of orbiting Earth with the vastness of the universe. Patterns in light, motion, and alignment teach both scientific understanding and quiet contemplation, a gentle reminder of home in a vast environment. The stars and planets serve as reference points. As you orbit, constellations shift slowly. Planets trace arcs across the sky over hours, and distant galaxies remain nearly fixed. Observation allows measurement of relative motion, the study of parallax, and awareness of orbital position. Each cycle of sunrise, sunset, and passage over Earth reinforces cosmic alignment. Patterns emerge across repeated orbits, teaching the rhythm of the solar system and its place within the Milky Way. Observation is immersive, continuous, and layered in both fact and experience. The station provides unique perspective for constellation movement. Seasonal stars are visible at different latitudes. Precession and rotation cause subtle shifts. Observation over multiple orbits allows careful tracking of relative positions. The Milky Way's band appears fixed, while stars within it show minor differences. Observation encourages patient awareness, noting changes over time, understanding scale, and reflecting on Earth's position within these moving frames. The night sky becomes both classroom and companion. Observation of planets, satellites, and Earth together provides perspective. Earth rotates beneath you, illuminated partially by sun or moon. Satellites move across the sky in arcs. Planets shine steadily. Stars form patterns in the background. Observation links immediate motion of the station with slower planetary motion and near static distant stars. Scale, timing, and position are interconnected, revealing both dynamic and stable aspects of the cosmic environment. Awareness grows as layers of motion become perceptible simultaneously. The night sky fosters reflection. Observing constellations, the Milky Way, and planets from orbit is both scientific and sensory. Light, motion, and scale intertwine. Earth appears small yet vibrant, its surface moving under the station. The universe beyond remains vast, structured, and continuous. Observation encourages patience, attentiveness, and a sense of connection. Awareness of distance, motion, and relative size grounds perception while emphasizing the immensity of space and the rhythm of cosmic systems. After hours of observation, you float back toward the sleeping quarters. The station hums softly around you, mechanical rhythms and subtle air currents blending into a gentle background. Handrails guide your path as you move slowly, adjusting each motion to the lack of gravity. Even simple tasks, turning a corner, reaching for a latch, or pushing a storage compartment, require careful attention. You notice how your body responds differently here. Muscles and joints feel light, almost unfamiliar, yet capable. Movement is deliberate, mindful, a series of small adjustments to maintain control while floating. As you enter the sleeping area, you prepare for rest. Your personal restraints and sleeping bag are ready, attached to the wall to prevent drifting. You slide inside, securing lightly, feeling the subtle pull of microgravity as your body aligns with the small chamber. Breathing slows naturally as you settle in. The station's ambient light is dimmed, casting gentle shadows across surfaces. Air filters hum quietly, producing a soft, constant background. You focus on the sensation of floating, the freedom of weightless suspension, and the gentle rhythm of your own breathing. Attention shifts to your senses. You notice faint sounds, the soft whir of fans, the distant clicks of mechanisms, the gentle vibration of equipment operating. None are abrupt, all are continuous and predictable. Even these small details reinforce your connection to the station, a living laboratory in orbit. Observing without judgment, you allow awareness to drift outward, toward Earth, toward the stars, toward the quiet motion of the station itself. You feel small, yet secure, held within a controlled, protective environment. You guide your own awareness gently. Start with your hands. Feel their position in space, the subtle movements needed to maintain orientation. Relax the shoulders, arms, and back. The body responds naturally, letting go of tension accumulated during activity. Muscles lengthen and soften, guided by gentle attention rather than force. Awareness moves downward, feet, legs, core. Every part of the body is recognized, accepted, and allowed to rest within the constraints of microgravity. Movement ceases or occurs slowly when necessary, and a sense of calm expands. Eyes adjust to low light. Through the small observation window, Earth glows faintly in the distance. City lights twinkle softly under thin cloud layers. Oceans reflect moonlight in narrow streaks. Clouds drift slowly across continents, forming patterns barely perceptible in real time, but observable over successive orbits. You notice the curvature of the planet, a gentle curve outlined against the blackness of space. The repeated cycles of light and dark, familiar yet altered by speed, fade gently into your awareness. Observation slows naturally as your mind accepts the rhythm of night. You begin to track your own breath. Inhale slowly, feeling expansion. Exhale softly, releasing tension. The station's slight motion is imperceptible in microgravity, yet the sense of orbiting Earth persists. Awareness of movement is subtle. The planet rotates, clouds shift, oceans glimmer, city lights blink. These patterns continue without interruption, independent of your activity. Allowing attention to soften, you integrate into this larger rhythm. Breath and body move in harmony with environment, encouraging relaxation and mental quiet. Visual focus drifts from specific points to ambient space. The blackness beyond windows, punctuated by distant stars, provides a calm frame. Bright points remain steady. The Milky Way stretches faintly across the sky. Movement of Earth below is slow yet continuous, providing an underlying rhythm. The gentle hum of the station accompanies this visual stillness. Sensory awareness is present but unobtrusive. Observation becomes passive, more felt than noted, as attention gradually shifts from details to broad, continuous patterns. Thoughts simplify, minute decisions fade, internal dialogue eases. Observation becomes perception rather than analysis. You notice a gentle pull toward rest, an inclination to close the eyes while maintaining awareness of position and orientation. Microgravity allows the body to remain supported by restraints and gentle contact points. Attention can fade naturally, guided by the quiet environment, predictable hum, and soft visual cues. The mind begins to let go of active monitoring, merging with the subtle motions and sounds around it. Time itself becomes fluid. Orbital cycles continue in the background, but individual sunrises and sunsets pass unnoticed. City lights pulse faintly beneath cloud cover. Clouds drift across continents. Oceans reflect light subtly. The station hums. Breath is calm. Awareness is present without focus. Sensory input remains, yet does not demand action. Perception and presence blend, creating a state between wakefulness and sleep. Observation persists without active attention. The world moves below and beyond, continuous and gentle. Internal sensations deepen. Muscle tone relaxes further. Heart rate slows naturally, and joints release minor tension. Mindfulness remains, but without expectation or analysis. Observation shifts to peripheral awareness, and faint vibration, soft air currents, minimal visual cues from surroundings. The station, Earth, and cosmos maintain motion independently, providing a consistent and safe framework. You allow attention to distribute evenly across sensory channels, reducing intensity in any one area. Relaxation becomes complete, fluid, and encompassing. You feel weightlessness fully. Limbs float with minimal effort. The body remains aligned with small restraints, yet freedom of movement persists. Microgravity becomes an extension of sensation, a gentle support for rest. Awareness of the orbital environment continues without active engagement. Sounds, light, and motion are registered softly, accepted, and allowed to recede into the background. Consciousness begins to shift from active observation to quiet reception. Mind and body synchronize with the continuous rhythm of orbit. Reflection emerges subtly. Awareness of Earth, city lights, oceans, and clouds persists faintly. Stars and planets remain visible through observation windows. The Milky Way stretches across space. The station hums. You notice these layers without holding on to any one feature. Observation becomes passive. Sensory experience is continuous, but diminished in intensity. Attention recedes gently, merging with environment. Sleep is anticipated naturally, without effort, as body and mind continue to integrate with the station's rhythm and Earth's passage below. The narrative gradually softens. Focus on details decreases. Thoughts relax. Awareness of external and internal sensations blends. Breathing remains steady and gentle. The orbital environment continues its motion uninterrupted. Earth rotates, clouds shift, oceans reflect light, and distant stars maintain position. City lights blink beneath clouds. The subtle rhythm of machinery, air, and faint vibration provides a constant, gentle accompaniment. Sensory input persists, yet attention fades toward passive awareness. Gradually, the mind releases expectation. No action is required. Observation continues, yet less intentionally. The continuous motion of orbit becomes a backdrop rather than an object of focus. Attention expands to include entire environment, station interior, Earth below, night sky above. Sensory awareness remains, soft and diffuse. Observation shifts into presence, allowing the mind to settle. Sleep becomes accessible, a gentle drift, guided by rhythm and calm rather than force. Motion, light, and sound merge with perception naturally. Microgravity amplifies the gentle process of winding down. The body floats with minimal resistance. The mind is aware but undisturbed. External cues, Earth, stars, distant planets, persist without demand. Internal sensations, breathing, heart rate, limb position, remain soft and diffuse. Awareness balances between interior and exterior, between presence and rest. Attention fades slowly, naturally towards sleep. Observation continues subtly, embedded in consciousness without effort. The station hum, Earth's subtle motion and cosmic background merge into continuous sensory presence. No single element dominates. Motion, sound, and light blend seamlessly. Awareness is passive. Mind and body relax further. Observation persists as a gentle backdrop, maintaining consciousness in soft, peripheral focus. The environment remains predictable, safe, and continuous. Gradual fading of attention allows sleep to begin, integrated with ongoing orbital rhythm. Eyes may close now or remain partially open, maintaining minimal visual awareness. Attention is gentle, unforced. Breathing, heartbeat, and posture remain steady. Microgravity supports relaxation. The station continues orbiting Earth, silently and precisely. City lights, clouds, oceans, and continents pass beneath. Stars, planets, and the Milky Way remain visible. Awareness blends with environment. Observation continues in soft, diffuse presence. Sleep is permitted to emerge naturally. The mind softens further. Thoughts quiet. Sensory registration persists lightly. Motion of Earth below and distant stars above continue. The body floats comfortably in restraints. Ambient sound remains constant and gentle. Observation is integrated, subtle, and non demanding. Awareness gradually transitions to sleep. Presence persists without focus, embedded in the orbiting environment. The day's activities, observation, and contemplation gently dissolve into calm, continuous experience. Motion, light, and sound provide a steady framework as attention fades. Time is experienced loosely. Orbital motion continues silently. Sun, Earth, clouds, oceans, city lights, and stars move in unbroken patterns. Breathing is slow, steady, and relaxed. Microgravity allows complete bodily comfort. Mind remains aware in soft, diffuse form. Observation persists as passive perception. Attention fades towards sleep. The environment remains constant, predictable, and secure. Awareness and rest merge seamlessly, allowing the transition from wakefulness to sleep in orbit. Finally, consciousness rests in gentle immersion. The station hums, Earth rotates, clouds shift, oceans reflect moonlight, and city lights blink. Stars and Milky Way stretch across the sky. Movement, light, and sound continue without interruption. Attention is minimal. Mind and body rest. Observation continues as subtle background awareness. Sleep begins naturally, uninterrupted, integrated with the continuous rhythm of orbit. Presence, observation, and rest coexist peacefully, fully immersed in the environment of orbiting Earth.